So today is the day in which we're gonna make episode 4 of this painful journey, which is gonna be a new hope because we do have a new hope called Nathan, and let's see how that goes. So this is the
Just
code that
perfect.
Nathan made for doing the thing that we talked about last session about doing it in a single fold instead of trying to divide and conquer. Because doing it in divide and conquer brings some weirdness and difficulty as well. So, so let's think about that. So, where do you want to start?
Expression.
Uh, okay, expression.
Uh,
This seems to be the same.
so yeah, that's like literally the same thing, I guess. That yeah.
I don't know why we have a list in here though.
Well, branches, right?
Oh, this is the only this one.
Uh-huh. Oh
Okay,
yeah, yeah.
okay.
We don't
Yeah,
have
so
that
this is
problem in
exactly the
Haskell,
same.
right?
Yeah, so this is exactly the same. Cool. So the first thing that I want to talk about is the types, specifically the pattern and the state.
Wait. Just one thing that doesn't matter a lot, but just so it doesn't get weird. Line 24.
Yeah, we also have a thing called constructor here.
Yeah, because we don't have that in our language because they are just functions, right? But there, that's the constructor of a sum case, right?
No, you mean
So
that, wait, I'm confused. I am confused. So this is serving which purpose again? The constructor
it's it's the constructor of a sum type.
is a constructor for some type. Why is that is not in the type data type?
Well, that's an expression, right?
Yeah, so which one we are using in our case here? That's a good question.
Well, we don't have one in our EST
Yeah, we don't have one, so I am kind of confused. So,
because
um,
all ours are just functions,
oh, okay. We
right?
are using the constructors as functions, and you're not doing that.
Yeah.
Okay, I got it.
So that's how you construct uh, some data with the type of a sum type, right?
Okay, so my guess is that this is the name of the constructor.
Yeah.
These are the things that you're gonna pass to it,
Yeah.
and I'm not really sure what is this, but can you give me a hint about that?
It's a type.
No, that I know. I'm talking about the semantics, right? I can read. So what is this type for?
My hint is that's a hint.
Wait, can you repeat that?
Yeah, my hint that you asked for, that you asked for, it's that this type there is a hint.
The type is a hint. The hint is that the type is a hint.
Yes.
Yeah, I have absolutely no idea what you mean by that, but I think we can go on.
Yeah. So the thing is, Lemos, when you have a constructor, uh, and it's called something like ABC, how do you know what its type is, right? How do you know that?
Well, in our case, we make a function that determines the output, which is going to be a type. So this type is this
Okay.
then, I guess. So this is like this is the name of the constructor, this is the name of the things that go inside, and this is the outer like the result. What is the type of this two? Is this?
Yeah, that's like a type annotation, right?
Yeah. Okay.
Because either you do like we are doing, or you do by some kind of inference, right?
Yeah.
You go
True.
into your context and check, oh, what are the types declared that has this constructor? And then
Yeah.
from there I know.
Okay.
But there, you don't have nominal stuff, you do this to annotate.
Yeah.
So that's the
Okay,
only
so
different
let's
thing.
let's talk about the constructor in the pattern data type now.
But wait, the types is much simpler, right? Are much simpler.
Wait, I don't know. You mean the types are much simpler? You mean these types?
Yes, yes.
Yeah, we have only literals and the sum type.
So just the same, right?
Yeah, I want to know these two.
Yeah.
So we have the pattern, we have the variable, which is totally fine. We have the wildcard, which is fine. We have disjunctive, fine. Literals, fine. Then my question is for the constructor and the S, which is a bad name, right? Because
Hey,
you can say like that, and it's like
dude, I find this. Wait, can you say what? How?
yeah. So the problem like
Okay.
Zozin does did this a bunch of times in his videos is that you can pronounce that as this, right?
S. Yeah, but I don't think that's a problem.
Okay.
Maybe that's a post-it. I
Okay.
But dude, I will not grab the link for you now.
Mhm.
But I was taking a look on something from Simon Peyton Jones. Now
Yeah.
I don't remember if it's a tutorial about creating functional language or if it was something like uh, typing Haskell in Haskell, and he calls it exactly that also S.
No, no, no. I'm
Just
not saying that because well, I'm not saying that the name is good or bad depending on who you use it. I'm saying that you are putting yourself in a very like people can understand it very
yeah,
wrong the
I
wrong
just
way.
like I just put in a note there. Right?
Okay, so what is the constructor pattern? Can we go on that? Wait, this
What
is this
is?
is the p sum type. Yeah, this is the p sum type. Totally. Yeah, totally.
Like on our side, yeah, that's exactly it.
So I don't know what this guy is for. This is a
Well,
pattern and a string. So you are just renaming it then, I guess. Like you pattern match and then you want to reuse it again. So it's kind of the at in Haskell, I guess.
yes,
Yeah.
exactly.
Okay, so that works. Okay, so let's go to satisfied. No, not satisfied. State. So this is the state for the fold, I'm assuming.
That's the magic. Yes.
Okay, so for some random reason, we have the literals split up, but I think we're gonna have just satisfied, literal, and then some type.
Some random reason. I don't know what you mean by that.
Yeah, you can just make a type literal. You don't have to type these 3 times, dude.
Oh, really? So take a look on the types
Okay.
of states.
Okay, so you have unit, you have literal, which is these three.
Yeah, take closer attention on int and bool.
Oh, these ones are list. That's right. And some of them are optional even. So you have a list of integers. Let me think about why. Oh, it's because of the same reason as before. We are accumulating in the bag which integers we are doing stuff.
Exactly.
And the boolean is the same.
Exactly.
The boolean is the same. Wait, the boolean is the same?
Yeah.
Are
Because
you
what are the states? Yeah. Because, well, you mean the same as we have in Haskell code? I don't know.
Oh no no no
That I don't
wait
think
wait no
so.
I know. So you start without a boolean. So this is nothing in the beginning.
Yeah.
And then if you find like a a true, then you put just true. And if you find a false after having a just, then you are just going to satisfy it, I guess.
Yeah, or the thing it's the same and I keep the same state, right?
Yeah, yeah. So maybe it's totally sufficient for the boolean, yeah. So sum we have a list of lists. So let me think about that.
I don't even remember.
I hope you remember for sure. So in the case of the sum, this is definitely because of the whole thing about doing the vertically that we are trying to do before. So we have I am assuming that this is a name. So this is left.
Yes.
And these are the internal stuff that we have. And then because you can have multiple lefts, then you have a list outside.
Yeah. That's it.
Okay.
Wait, not quite, not quite. That's not multiple lefts, right?
No, there are
They
multiple
are.
different patterns that are always all
No, no, no,
sum.
no. Wait. I'm saying that there, where you are, that pattern, they are not different lefts inside this data type.
They are not
They are
different
different
left.
constructors.
Yeah, so that's what I said. It is everything that is a sum pattern, it will go into this outer list. Not necessarily a bunch of lefts, but in my mind, I just set it to be easier. But it can be a
Okay.
right, it can be whatever. It's totally
No,
fine.
yeah, but it is a important aspect of it that uh, you will not have anything repeated there, right?
Yeah, it's an important aspect of it because if you do have a repetition, you just need to see a warning, right? Instead of
Uh,
putting in the back, you just show a warning.
uh, to clarify this, it's better to take a look on the code that is using that. Go to get initial state.
Get initial.
Yeah, that will help with it. Uh,
Okay, so if you have at the type unit and int and bool, you just do you basically create the bags, right? So you have empty
yes.
list, you have a none there, and in the case of the sum type, you go through the list of constructors and you go through the second members of them and you map it again. So it's a recursive function with the get initial state. Yeah. And then you use state.sum. What is that? Um,
Well, that's just wrapping the
oh, that's
constructor
just
sum, right?
rewrapping it again because you use the constructor instead of. Yeah. That makes total sense.
Yeah, but what is the important piece of that code? Given that type, the initial state that I'm building from it, it's that, like it's built from it. So I don't have an empty list on the beginning and go adding those. They are there from the start, and I just keep updating, you see? So
Wait,
from
wait,
the
wait, wait, wait.
start,
What you said is really important. It's not
yeah.
an empty list. It's already there. How do you know the ones that are already there?
Uh, what did you understood by are already there?
Um, my understanding is that this list of constructors is not empty. It is never empty.
Yeah, because that's the type,
The
right?
question is, how do you start the process, right? I think that's what I'm talking about.
Which
Oh,
process?
I know. Okay. So you're going to the list of constructors that we know we already have because we already know we did the match. So the value
Yeah,
that we are matching, we already know it is. So
we
we
know
do
it
have a
has its
left and a
style,
right
right?
in here.
Yes,
We
yes.
already have that information. That makes total sense. Okay. Then you are, okay, that makes sense. That makes sense. Why it's not an empty list. That makes sense. It was really helpful, this. I agree.
Yeah, because taking a look on the type, you cannot say if the thing starts empty and then you'll be adding, right? Like that's not included on the type.
Yeah, the type is already giving you that information out of the box. If
No,
the
no.
type of that
What I
value
mean,
is an either, you already know you have lefts and rights as the sum type potentially, right?
yeah, yeah.
We already know that. Yeah, okay, that's cool. So where do we start? What is
So
the entry point of this?
yeah, take a look on. Well, go like after the types, like right after.
Okay, here.
So yeah, like there is some info there that we don't care. But type equal, I don't know if it's interesting to take a look on the equality of the type sum. Uh,
Okay, I
well,
think it may be interesting because what you're doing there is you're grabbing each one of the sum types. First of all, right? You are basically doing like everything needs to be int, bool, bool, etc. Everything else is false, which makes total sense. But if you have constructors, you grab the list that is inside each one of them, and then you apply something called list equal, which is basically checking if the length is equal and if the elements are equal as well. That is my
Yeah.
understanding, which is
Yes.
yes. Then the wait.
I pass a quality function, right?
Okay, so you're basically making a type class out of like from scratch.
No, no, it's exactly the opposite. Since I don't have a type class, I
You
don't have an implicit equal. I have to pass one function
yeah no.
for
Then you're
equality.
creating one. This would be exactly like the equal type class implementation of the tuple and the list, I guess. We can even take a look on the source code for them, but I'm pretty sure that if
Yeah,
you
that's that's not the point I was talking about. I was talking about the point this function is exactly that way because we don't have type class concept there.
no, that I understand, but what I'm saying is that you're basically doing the implementation instead of just using
Oh,
it like like I said, these probably are implementations of the equal for lists and tuples in Haskell, with a different syntax, of course. But anyway, so you're passing. Oh, I see. So this equals is a function that you're passing it here. So this is this. Um, question type equal list equal.
yeah. Take a look on
Oh,
the
okay.
the
So this is
list first.
recursive. Yeah. So you're grabbing that you are doing equality on the tuples, but you are also passing this to them, and this is this. Okay.
Wait, why do we pass? What the?
It's your code, dude.
Oh, okay, yeah. I passed the equal because it's a tuple between like a string and types or something like that, right?
Yeah. And then you do a list sort, and this is the important part, I guess, because you are sorting them.
Yeah.
So this is something that we need to take care of before we do the equality. That's for sure. That's for
I
sure.
mean, we should have this implemented already, right?
Um, I don't. Good question.
Oh, that, come on, there is no way.
I think there is a way, yes, but data
Okay,
type.
but
Because I think we are just, yeah, we're just deriving it. We are just deriving the equality for the entire thing.
wait. Go back there. Uh, type T algebra.
Yeah, this is the T
Good.
algebraic, and then we're just doing this. I think we already had this discussion before. Yeah, we totally had that because we already noticed that that to every single time that we want to compare T algebraics, we
Oh,
need
we
to
are there first.
we need to do a sort, and then you said, yeah, but why we can't just put that as an implementation of the equality? And then I said, because if we do that, we're gonna have to do every single one.
Yeah, so then I would be sure that, well, not sure, but I would think that we say that, oh, so let's just sort always, like before doing the equality, right?
Yeah, but eventually we will. And I agreed back then, and I'm gonna agree it now again, which is that after we have the first draft done, we should totally go into here and implement the equal to not have to do those
Yeah.
sorts there. Anyway, so this is the type equality, pretty okay in my opinion. So let's go. There is a to do there. Should error when a given type doesn't have a possible valid pattern like a function type? When a given type doesn't have a possible. Oh yeah. This we have that function. This to do we already did. We already do have a function that matches the pattern with a function with a type. Sorry, with a type.
Um, I'm not totally sure. Like, I remember we had something.
No, we have this function here.
Yeah, I don't think it's the same function.
Wait.
Go
Based
there.
on what you're saying, you want to match. We want to make a correlation between a type and a
No, no, no,
valid
no,
pattern.
wait. You only read the to do. The to do is the same. If this gets a type that it's not possible to match, like a function type, you give an error. I'm not talking about all the behavior that the function does.
Wait. Repeat that
So,
last part.
well, better than that, let me say what the function does. You
Get
get a
type
type
lengths.
and you
Yeah.
get a pattern.
Yeah.
From that, you generate the binds that the pattern will generate.
Oh, this
And
function we skipped because it's too long. And yeah, it is too long.
and some things to take notes is we don't get a name there, right? So it returns the binds. It doesn't increment the env that we passed to,
Yeah.
right? I don't think we would need that anyway.
Why?
And well, because I don't think we do.
Well, but that.
Why I haven't done this way is because, first of all, if we don't need, then, well, this is just more generic.
No, no, yeah,
And
but
the other,
from my point of view, we need. Why we don't need?
well, I just want to see where are the binds generated. So if I want to increase them in my env, I just do it outside this function.
Oh yeah, we can totally do that if you want. Yeah.
And if I had the env, that would be a problem in some of the checks I'm doing there. For example, when I want to check if, oh, you cannot repeat a bind, then I cannot do that in the environment, right? Because a bind could be there even before we call this function. So
Yeah, but
that's why.
that's what you like. That's shadowing, right?
No, you don't get that. That makes so it's not possible for us to do a check if there are repeated names into the same pattern. It becomes impossible.
Oh wait, you're talking about same names within the same pattern.
Yeah, that
Oh.
shouldn't happen, right?
Oh, okay. I was talking about a different thing because
So yeah,
yeah, yeah, okay, that makes sense.
and besides that, this function also validates with type can match with patterns, right?
Which types matches? Oh, I
Well, which patterns
see.
can match its type, right?
Yeah, 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 yeah. So what you did actually is that you fused the two functions that we did separately. That's cool. So instead of
Well,
having two
because
different functions doing two different things, you have one function that does both. So
yeah,
this
kind of,
and
right?
that create binds.
Because take a look. Checking if it is valid or not is just a matter of you getting this function is if it's successful or not. Do you agree?
Yeah.
So yeah. And the other thing is checking if it is valid, like just returns a boolean, doesn't give you shit.
Yeah.
You still need to pattern match to like actually use this stuff, right?
Yeah.
So just do it this.
Yeah, okay, that makes more sense. But let's go from one by one to see if everything makes sense. So these two makes a ton of sense. Let's go to the OR pattern though. So the OR pattern is composed out of
As
okay.
simple as it can be.
Yeah, so it is 100% nested, I guess. You have a thing and then another OR and then goes on. Instead of having a list, which is I don't know how I feel about that. I think it's easier because then you can just call the
It's
thing recursively.
much easier if you have only two.
Yeah, so you pick the first, you pick the second, then you do an if. What the heck this if is doing is a good question. So least
Yeah, I should
equal
have put those in lats with names like.
binds A binds B.
No, no, no. I mean, what is inside the if, right? Like, I should have given a descriptive name for what this is doing, right?
Yeah, so can you give me a hint on what this is doing though?
I don't know. Let me
What
see.
the heck this is doing, dude?
Yeah, I'm just checking if the binds are the same.
You're just checking if the binds are the same.
So you
Okay.
see, I'm starting the list of the binds, right?
Wait, so then what you're doing, you're verifying if you have repeated names inside the ORs.
Wait, no, no. I'm checking if the binds are the same.
Yeah, no,
That's a
but
bit different.
no, wait.
Like,
That's
they
I
are
think that's
exactly the
incomplete. I
same.
think that's incomplete what you said. Can you repeat?
Yeah. So what I'm checking there,
Yeah.
if I'm checking if the binds generated by the pattern A are exactly the same binds generated by the pattern B. Exactly the same.
Wait, so okay, so the keyword there is exactly. So if you have some binds that are the same and some other binds that are not, then you're okay.
No, that fails, right?
No, wait, but that's what I want to understand. So what you're doing is you're going through all the options in the OR and you're verifying the binds.
Yeah.
My question,
Getting them, right?
yeah, you're not only getting, you are doing an if that is
Yeah.
doing a list
Also,
equality.
no, I mean the get type binds recursive there.
Yeah. So my question is that what this if is doing is checking if all the binds in recursively are all the same. So let's suppose that you have a left 1 and a left 2 inside the OR pattern. Okay?
Yeah, yeah,
Okay.
okay.
So this will return an empty list, right?
Yeah,
And this will return an empty list as well.
yeah,
Okay, so to be like easier to understand because we have two empty lists here. Let's say that you have a let x and a let 1, okay? So then the left x will be this. So it's going to be x and the type whatever. And then the 1 will be only empty list, right? Does that make sense?
yes, yes, this,
Okay, so now you're grabbing the list with this tuple and an empty list and you're checking if they are equal, okay?
yes,
And if they are not equal, right, you're gonna fail. What does that mean?
yes. I don't know what you mean by that.
That means that you can't have. Um, that's kind of weird.
Oh, okay,
Wait,
yeah, that's very important for you to see. So why can't they have different binds?
that's a good question.
It's because they are pointing to the same range, right?
They are
So
pointing to the same branch.
yeah, let's suppose I use X inside the body of the.
Oh, I see. I see. I can see. I totally see now. I do have a question though. I do have a question. Do these let's okay, so what you're saying is that you need to have the same binds because they are all going to the same branch, and if I want to use X and they are not the same, that doesn't make sense, right?
Yeah,
Okay, so the question.
exactly the thing we were talking about the other day about Haskell top level stuff.
Oh yeah, that's what we were talking on the server, yeah. So my question is, um, what if you want to use X into, but the patterns are not the same? So let's suppose that you have like a
That's very
left,
good. That's very good.
like if you have a left X and a left of a just of X, right? How does that goes?
Well, what is your type?
Um, let's suppose that is an either of a maybe of one and
I didn't even
whatever
know we were streaming today.
and whatever,
Wait. Let me.
right?
Uh, dude, this card is very weird. I have to like go up with your volume again. Can you repeat, Mageta?
I
Uh,
just said I didn't even know we were streaming today.
yeah, we swapped Tuesday with today.
Yeah, okay.
So, Nathan, do you agree that um, if you have an either of a maybe there, so how do you tackle having two x's, right? But they are not the same thing. Can you use the
So
OR
yeah,
pattern?
so yeah, that's the thing. If they have different types, then that's an error.
If I have
Have
different
the
type.
same bind means the same name and type.
Oh, the tuple is already doing that for us because it has the identifier and the type of it.
Oh, Grande is here, man.
That's
Hey,
very interesting.
Hello, hello.
Hello.
how you doing,
Hey,
guys?
never talked to you, but hello.
We are doing great. We are doing great.
Okay,
We
can
are,
I join here so I
yeah, of
can learn
course.
something?
Yeah, of
Okay,
course.
I would just hear this weekly session.
Okay.
Lemos, can you state what we are doing right now?
Yeah. What we are doing is we are going through an implementation that I made of pattern matching of the functional language that we are implementing. That's what we are doing.
Right.
So because and that's the thing. This is the fourth session just about this topic because no, actually it's the fifth because the first one didn't have the actually it's the fifth one. Because we tried the strategy of trying to do pattern matching properly and that didn't well. We don't know for sure that that would never work, but it's definitely
It's
hard.
likely.
It's hard as AF. So then Nathan suggested a different approach that it seems that he accomplished that, and we are going through the Ocampo code that he made to implement that before.
F sharp.
Oh, this is F sharp? Okay.
Yeah.
So we are going through the F sharp code that he made before we translate that to the Haskell implementation. That's what we're doing. So, Maget, are you still there?
Yeah.
Okay, so let me explain to you what we did so far because I think I understood enough in order to explain it fast. So, what we are doing is, just to remind you, instead of doing divide and conquer to like divide the
Yeah, that's
aspects
I
of
remember
pattern
you
matching, we are gonna do a single fold with checking everything at the same time. Fine? Okay. So the most important thing, I don't think it's worth it to pay some attention to these. Just forget about these. This is the important data type, which is the state of the fold in this case. So the fold can be satisfied, it can be unit, and then if you have a number there, remember that when we implement the numbers in other sessions, we are saving which number it is.
Yeah, so you can always infer.
Yeah, so then we have a list there. And we are doing the same with the boolean, but Nathan, instead of using a list, he just used a maybe because it's better in this case, because there's only two options. And then this is the sum type, right? The sum type of the that we want to pattern match. So this is at the left that you want to pattern match, like the either. These are the internals, the internal things of the left that you also are pattern matching, and this is a recursive ADT, right? And then let's suppose that you have multiple sum types that you want to pattern match. Then this is what this list means.
Well, not multiple sum types, right? Like you have multiple constructors
Yeah,
for
left, right, that's what I meant. That's what I meant, sorry. Okay, so then this is basically infrastructure to have equality working to make the thing. And we stopped and we are at the get type binds, right? So what this function does, it grabs a type, it grabs a pattern, and it gives you the binds to go to the body. Okay?
Let me see. Just let me take a look. Just a peek on the
Yeah,
code.
so let's suppose that you are pattern matching with a variable. So you are just doing x. So you're gonna send to the body that you have an x, and that type of the x is this. Which is in this case is the entire either, right? So imagine this is the
makes
either.
sense.
Yeah.
A wildcard, it's nothing.
Yeah, wildcard is nothing. And there's another thing. This function does two things at the same time. It does that, create the binds, but it also checks the relationship between a type and a pattern. Because if you have, like, remember that we did that before, that if you have an integer, the pattern can only be integers or wildcards or whatever. This function is also doing that. So they're doing both things at once. And Nathan had a very great argument about like having them separate doesn't give you a lot of like it's very inconvenient because you having a boolean to check if the type and the pattern are okay, it will give you nothing. Just better to do all at once. Okay. So the wildcard and the variable, and then the OR pattern is cool. The OR pattern is cool.
I just read it.
So what we're doing that we were discussing that I still want that Nathan just answered is that we are grabbing the OR that Nathan made is not using a list, is using nesting stuff.
Okay, yeah.
Right? So the OR instead of being a list of patterns is
it would be an OR. It would be like a tree, right?
Yeah,
not a
it
tree.
like an OR inside an OR inside an OR,
yeah,
and so on. Exactly.
Then S is not the normal. Is it the normal binding or is it the pooning?
Wait, what was the question?
For example, like X or is it like SX? Like what is the?
Oh yeah, there is a difference there. So if you are doing S, which is like I'm gonna say again, it's a bad name for dark reasons, but um, if you're doing that, if you're doing that, we're gonna save the entire pattern and the name for it, and that's different than having like the bind X inside the pattern, right? Do you agree?
Yes, I agree. That's what I'm asking. Like, so the S is basically just picking all of the expression, right? The other one is
Yes.
just finding one
Yeah.
element out of the expression.
Yeah, we
This
are.
is not in there, I
Yeah, we are
guess.
pattern matching, but I don't know this for a fact, but I'm assuming that the implementation of the as is that we're gonna do whatever
Okay,
with the
but
pattern,
you
but
can.
we're gonna throw this into the environment.
Yeah, but you can nest, right? So, for example, you can do this on a pattern inside
Yes, you
another.
can
Right?
nest. You can
Yeah.
nest.
Okay.
Okay, so then what we're doing with the OR is we are calling the function recursively, the get type binds, with the internal ones. So you're gonna basically deconstruct recursively the entire OR pattern. And for
Mhm.
each members of the tuple of the OR, we are checking if the binds are the same. And that's important because if you have two, like if the binds are not the same, how the heck are you gonna use them inside the body of that branch? So if you have like in this part, like exactly this case, for instance, so you have an X, and then you're
Mhm.
doing an OR, and the other X is actually the value inside the maybe.
Yeah, this is shadowed by the other, right?
Um,
The second is shadowed by the other. That's what I mean.
no, that's correct in that sense, but Nathan's point is that that's wrong. That we should give an error if that's the case, because how the
I
heck you
think
gonna
we're learning.
know which X you're gonna use? Because
Oh, I
these
see.
two branches, these two patterns
Yeah,
are going to the same
yeah,
branch.
makes sense. How do I know what is the type, right? I need to
Exactly.
infer it either to be a maybe or yeah, makes
Yeah.
sense.
Okay, so that's where we stopped. So this is the OR. So now is the S. So you have the pattern and the type there, and then you call recursively to get the binds. Then you're doing. I don't know what is this, Nathan.
Position is composing with equality and on the ident. I don't know
Oh yeah,
what
this is the
identity.
compose. I
Ident.
remember now.
Yeah.
Okay, so you're composing first.
It's checking if the first is equal, I guess.
Yeah, it's checking if the first is equal to ident.
I
And
don't know
you're.
what is ident.
Oh.
Probably identity,
Oh,
but
I know what
yeah.
this is.
Yeah.
This is checking if you have the same name in like nested S. Oh my god, I almost said nested S's, but that's bad. Okay,
Okay.
you're checking if you have more than one. Because if you
More than
do,
one.
more than like if you have internal names of the binds equal to the ident, you have two different things with the same name.
So it's like the same thing as the R, but with only one, right?
Yeah, basically. And then if you
I,
don't, we just put that into the binds, and that's it.
yeah, I just wonder something. I'm not doing the check on the type there. You see that I'm only doing on the identifier, right?
Yeah.
Can this be a problem somehow? Like at the time I didn't saw that, but let's think about, right?
What do you mean? Do you mean that you should be also be checking for the type?
Oh, okay, yeah. I think I'm only using indent there because I want to see if it's different, right? In the other case, I want to see if it's equal. Like,
Do
into
this.
the OR case, I'm checking if both
Yeah, yeah,
sides
yeah,
are
yeah, yeah,
equal,
yeah.
right?
Exactly, exactly. It's the reverse logic. The or you're checking if all of them are equal, and in the
Then it needs to
as,
be exactly equal, right?
then it needs to be exactly equal. That's for sure. That's why you're using the tuple equal instead of doing the composition there. And then in the as one, you are checking if they are all different, I guess.
Not all different, right? But if this one is not inside the other ones,
Yeah,
I
yeah, yeah,
don't care
but
about the
like
type, I guess.
it's nests, right? So because it's recursive, so you can have S, like nested stuff, and if
Mm-hmm.
any of them have the same name, I think this will explode.
I think we have a question on this.
Excuse me, can you
Hello?
please zoom in your browser?
Yeah.
Because one more time, please. I think it's better now.
Okay,
Now
no
now I
problem.
can read.
No
Thanks.
problem. Thanks for the feedback. Go, Nathan. What's the question?
The question. No. Grande made the question, right? Or he's raised his hand.
Oh,
Yeah, I raised my hand in the into Discord.
oh, I thought you said. I think we have a question, Limbs. Like we have a question to answer for ourselves, you know.
No, it was me.
No, because this
Thanks, by
happens
the
all
way.
the time. Like Nathan says, I think we have a problem. I think we have a question to answer. It
Don't
happens all
say
the time.
question, man. Only problems.
Okay, so now let's
Right.
go to the big boy, the sum type one. So this is the list of constructors of the type, right? So this is like the left, the right of the either that we already know we can have pattern there. And then this is the patterns themselves. So this is the left, and these are the things inside the left. Yeah. So then you're doing something calling that types, right? And then you're doing a try find. A try find. What the try find returns, please?
Maybe element, right?
Okay, so it's
Given the predicate.
okay. So returns an option out of that. So you are trying to find an identifier in the constructors that is equal to this. Okay, that makes sense because here we have the left and the right. We know that they are possible alternatives, like options to pattern match, and this is the one that the user asked for to pattern match.
Yeah.
So then we are checking if it is there, and if it is, we are grabbing the second. So we are grabbing the patterns.
Thank you, Nathan. This is so readable.
No, we are
Wait,
not grabbing
what?
the patterns. We are grabbing
Okay,
the second of this
was
thing.
no, dude. I'm writing COBOL for like weeks now. When I say COBOL, it's like SQL, which is COBOL.
Magenta, the thing that I was really glad about was this pipe into function, dude. That helped so much.
Okay, the inside the pattern, right?
Yeah,
Inside the,
instead of
yeah,
doing the match.
yeah. In SML, everything is already a pattern, so it's like easier.
Uh,
Okay, so what is inside the constructors again? Because I already forgot. Sum. Oh, it is this. Okay, so no, it is this. Sorry, it is this. Which sum? We have two sums, so I have to remember which one we are dealing with. Type.sum. So it's the one up there. Okay, so we are grabbing the list of types. Okay. Okay. So we are grabbing the list of types of the constructors. We are grabbing that here. Then, what are we doing with that? Are we? I don't think I know what is happening here.
Let
So
me read.
not enough F sharp
It's
for me.
constructors. Then another pattern, which is a constructor with what is this ident, I
It is
guess it's
this.
identity,
Identifier.
but identifier. Okay.
Yeah. So he's basically going through the list of
Pattern.
the possible patterns for possible constructors for the either and checking if the name that the user asked for is inside that. That's
All right.
this.
So he
If it
picks the
is, you're
first
gonna grab
one.
the internal list of types that the left or the right
Yeah,
has.
so he ignores them with the thing that possibly you cannot find.
No, but that's what I don't understand. What is this?
Oh, you are piping to a pattern matching. Like you don't. There are two ways to pattern match: the match and the function. The match you cannot pipe things to it, but the function takes one parameter that is a
Oh,
function. So
I
it creates
know.
a
Okay.
pattern match.
I think I know now.
Oh, and that way, Magenta, we also get a way to pipe into an if, right?
Yeah, yeah. Mm-hmm. So you
Okay,
also
so
eliminate.
so you're checking if you don't have types.
So if it's known, it's failure. Okay.
Yeah. So if you
If you
have
have
types,
something, when a list of that has a different length than the patterns you specified, then you
this is
have the
another
different.
error,
Oh, yes,
which
you
is also a
mismatch,
problem.
right? You're lacking
Mismatch.
Dude,
something.
take a look on the size of that string. Read that string,
Yeah.
please.
And okay,
Oh
so
no.
error
Oh
about the
no.
different lengths of type carries in a pattern. A way to improve this. There's a to do in the middle of it. A way to improve this would be checking the length problem in the same iteration that goes check if the pattern is valid with a given type. This way more accurate error can be given.
We decided on this.
I think, yeah, man. I think I prefer the object reference not set to an instance of an object. This tells me much more.
Okay, but if you do have the types, and because it's not going here, that means that the length of this and these are the same, which is correct. So the length of the types and the length of the things that the user pattern matched are the same. That's cool. So that will give us the type. That makes sense. Then we are grabbing that. We're grabbing that and the patterns. Okay, so and I think we need to do something cool with them. So get type binds. This is the function that we are. Get type binds, yes. Okay, so this is grabbing one by one of this and mapping that.
Yeah, that's your zip width, I guess.
Zip width. Yeah, this is the zip width. And then you concat them to return to, instead of having a list of lists, you have a single list, right?
Yeah.
Yeah. Okay, so these are the binds with the correct types. So this is like a name and a type. Does that make sense?
Wait, can you repeat that?
Yeah, so the type of binds is a list of tuples in which the first member of the tuple is the name and the second member is the type. Of all the...
Almost, I guess.
Almost,
That's a
I guess.
list of lists, I guess.
Yeah,
Even though I'm doing a concat.
Wait, if you're doing a concat, what do you have after that? Isn't that only a list of tuples?
One last list.
Yeah. So instead of having a list of lists, because this is returns a list of lists as far as I understand.
Oh, sure. Okay. Yeah. Then it's flatten, I guess, indeed.
Yeah, this is flattening. Okay, so then you have all the binds that you want to put into the environment to execute the body of that. What we are doing then? We are grabbing that. We are grabbing the names. We are grabbing the names, and then we have a list of names. Then you fold everything, doing a function that grabs a set and a key. Is this? I don't recall. In F sharp, the fold is from the left or from the right?
Left.
Left.
Yeah,
Okay,
there's
so
a
this
fold
is...
back that is from the right.
Okay, so this is the accumulator then. Does that make sense?
Yes.
Yeah.
Mhm.
Okay, so then you pick the name of the key. You see if it already exists to see if you have repeated binds. That makes sense. Otherwise, you just add to the set. And the set is the correct abstraction for this because we can't have repeated bind names, yes. And then you just ignore that. So
Because the result is a set, right?
the result is a set. So this is just a check.
Mm-hmm.
Yeah.
Yeah, just to see if there is not any repeated binds in the...
Yeah, that
The
makes sense.
same.
Yeah, that makes sense. Okay, now we pick the same binds. Oh no, this is just returning it because this is the pattern match of the beginning. So this is the continuation of this. Okay, so that's it. You just return the binds. Yeah, that makes sense. Then here you're checking if you have the int and the int, and everything will return that. That makes sense. Because you don't have binds if you have numbers and trues and falses and unit. Everything else, not everything else, because then I don't think you would use this or, but all of these combinations, they go all to an error.
Yeah, that's everything else. They are there. It's just if I add the...
Yeah, new type or a new pattern.
Yeah, he reward.
Yeah. Okay, so this is to get the binds. Okay, that makes sense. So this is the get next state. I'm assuming this is the fold function. The function being used in the fold. Is that correct?
Well, both are being used
Yeah, but
inside the fold.
Oh, okay, so both are being used inside the fold. So what gets next state picks a state and a pattern and updates the state, right?
Yeah.
Okay. So if you are satisfied, you just say that you are satisfied, and the
Oh,
current
okay,
the
something
current
else.
pattern is just unreachable. That makes sense.
Yeah, that's important. That function being the one that does the warning about unreachable case, it's an important fact.
Oh.
So it goes to the next state and also validates unreachability and gives warnings about it, right?
Yeah, okay, so something that I forgot. So we still didn't see the function that is doing the exhaustiveness check, right?
Yeah.
Okay, so
Well, it's kind of this one, like part of it. Big part
okay,
of it is
so
that
you
get
do
next to it.
separate them, but you separate in different functions that are all in a single fold then.
Yeah, you will see what the type check is doing.
Okay. So let's see. If you have a pattern but you are already satisfied, that's unreachable. That makes total sense. If you have a variable or a wildcard for whatever the state is,
That
that
is
you
not satisfied.
that no that is satisfied, right? This is what is
No,
written in here.
no, no. I mean, the wild card on the left cannot be satisfied, right?
Oh yeah, sorry for that. It can be
Because the
whatever aside from
original.
satisfied. Yeah. Okay, so then you're gonna be satisfied because every single pattern, every single type can accept the variable in the wildcard. That's great. If you have something that is, if you are unsatisfied, well, if you're not this,
Not satisfied.
yeah, then but you have an or, you're gonna call recursively the get next state with the first member of that tuple. That that makes sense.
That's the part that Chap screws up.
Why?
Because he does it in a weird way that gives you bullshit results.
No, I don't know what you mean, but okay. Then you're gonna pick that and do the same with the B, and that will do the entire OR. Yeah, that makes sense. That makes sense. Okay, next, if you are not satisfied, but you have an S, you're just gonna pick that. You're ignoring the name.
Uh,
Okay, that makes sense because you're ignoring the name
Wait,
because you don't care about the body at this moment. You only
Lambus,
care
and
about
forget
updating
that.
the state.
Take a look on the chat.
Take a look on the
That's a
chat.
OR pattern, right?
Yeah.
That should give you a warning about unreachability, right?
Oh, you mean because you're using the... They are the same.
Yeah, they are like the same thing, and are in the OR pattern, right? F sharp doesn't give you a warning about that.
Oh, I see what you mean.
And have some even worse cases, like less harmless cases.
Yeah. Okay, so yeah, that makes sense. But I need to remind myself that this function only updates the state. I don't need to care about updating environments and check putting that into executing the body. I don't care. I just care about updating the state. In that case, it's just calling the get next state with the pattern inside the S. That makes sense. But if you have a state.unit, you can only have a pattern.unit, yeah, because you already checked if you're not using variable in wildcard. That's totally true. Okay. If you have a state boolean and the pattern is not a boolean, same story.
Yeah, the order there is that besides I'm checking that I already used variable and wildcard, I'm also checking that I also use the OR and the S first because they also can appear in any type, right?
Yeah, the order matters. The order matters. Yeah. But something important to be here, your boolean bag is empty in this one.
Yes, very
So, and
important.
just for the record, Mageta, you're not here last session.
Yeah.
The bag is what like our memory, what we already pattern meshed.
Wait, the what?
I don't know who came up with that name.
The
Maybe
bag
probably it
is
was me.
what?
Probably you, Lem.
But I was talking to Nathan about accumulators just long, right? It's too long
So
to
you
say all the
call it
time.
bag.
Yeah, you just put it in your bag.
I see.
So this case is when you don't have in the boolean bag you don't have anything. That's why you just grab it and put it in a sum with the pattern because you don't have anything to say. Oh, we already passed that pattern, right? And that makes more sense if you read this because this is when the bag has something. Then you grab the internal thing that is on the bag, and you grab the thing that the user is trying to match, and if they are the same, that means that you're using true twice or
Or
more.
false choice.
Like you are doing like false, false, true, true. Like you already did that before, so we should say that the second branch is unreachable. which is the case in here. And if they are different, that
It
means that
just
you use the
returns
false.
itself, right?
Exactly. That means that this is false and this is true, which is totally fine. Then you just say that you are satisfied because you already exhaustively checked the boolean. Okay. Then it is kind of the same thing about the integers. Oh no, it is not because this is always a list. So this is or an empty list
It
or
is pretty
something.
much the same.
Yeah, no, but this you have two matches. Here you have only one, but you can do that because this is always a list. This is not like in this case that you have a none and a sum, right? So if you have the bag of previous integers and you have the pattern that the user is trying to match with the number, you see if the number that the user is passing is already in the bag. If it is, that means that it is unreachable. And if it's not, you just cons. That makes sense. Okay, big boy time. Sum type. You have the list of constructors, yeah, and then you have the pattern or that user is trying to
The
pattern
names
match.
there are pretty rough, Lemos. On that piece of code, the names are very strangely bad, man.
Strangely bad. Because normally they are normally bad. Now they are strangely
No,
bad.
usually they are not so bad.
Anyway, so this is the state. Again, state is always a bag. So this is the state of the constructors that you already meshed.
Oh, wait, you didn't show the get initial state to Magenta. It's very important there, right?
Yes,
Okay,
initial.
yeah, there is a function called initial, which is the first bag. Like this is when you start a
Mm,
thing. What do you have in your
okay.
bag?
Mm-hmm.
You have, if you have a unit, you just say that if you have this is making a relationship based on the type, right? So the get initial state, if you have a unit of the bag, is having a unit already. If you have an
Oh,
integer,
it's actually looking for a unit, right?
yeah, it's looking for a unit, looking inside the type. I mean, that's what I meant. But if
No,
you
what
have
I
an
mean is state.unit is not I have a unit. It's looking for a unit.
Yeah, the same for the.
state.unit.
Yeah, it's yet to receive a unit. I just expect
Yes.
this kind of thing.
Wait, phrasing like that didn't work for me. Can you repeat that, Nathan?
Yeah. So state.unit is the state in which I'm looking for a unit, not that I
Yes,
have one.
yes, 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 yes,
It's just a
yes.
way for you to be able to loop to accumulate multiple different things, right?
Yeah, the already having would be dissatisfied, right?
Yeah. Okay, that makes sense. That makes sense. But Magetta said something that I didn't think about. You said that this is a way to have multiple accumulators?
Oh, it's all on the same fold, right? As
It's
far
all the
as I
same fold.
understood it. Yeah, so for the same fold, you need to know what to expect on the state. But how do you couple multiple things that have different conditions?
Yeah,
Like,
that's very important, Maggot. That's very fucking important, dude. Because what you are doing, you would never worry because of that, Lenos. Because of the way we are doing your bag
No, no,
in
but
Haskell.
that's the thing. That's actually something that I was kind of confused because when I saw the state type and I saw that we are accumulating different things, my first instinct was that, wait, how are we gonna mismatch all this crap? Because we can have booleans, but
Wait,
you're also gonna have
mismatch or mix and match?
mix and match.
Oh.
My mind that we have integers and booleans. How are we gonna accumulate both? Are we using like a tuple or something, whatever?
Yeah, no, because if we were, that's the problem, right? They could not be nested then.
They could not be nested. So is this function doing?
That's
Wait.
why we cannot have something like a list as the bag, right? It needs to be one of those states. It could not also have something, well, not that it could not, but it would be very bad if I had something like state.empty, right? That would be also bad for
Wait.
some checks.
So during each step of the fold, you are
No, that's only called once, right?
That is
That's the
only called
initial
once.
folding state.
Yeah, but I still don't understand how this solves the problem of having multiple bags, multiple accumulators in a single fold.
Well, what solves that? I think it's the way that it's the way that the pattern uh, constructor is. Well, the state sum is built. That solves the nested things.
Okay, so you're saying that. Oh, I see. So when you call something that is nested, you just provide a new bag. Is that right?
Yeah,
Yeah.
yeah. The next state. No, okay. Two things. If you go into the get initial state, you will see a recursive call,
Yes.
right? So there is that.
Mm-hmm.
Uh, and if you go to the get the next state of the sum, you will see that I inside recursively apply them, right? So on their own bags.
Oh man, I see. So the way that you do is that as you nest stuff in the pattern matching, we keep providing you new bags. Like
Yeah,
if you have a left
no,
of a
all
left
the
of a just
bags.
of whatever.
Wait, all the bags are provided from the get go, right? The initial there, you already have all the bags that you ever are going to get. We just update them, right, in the future.
Yeah. What I mean is that when you call this at the first time, all the bags are initialized. Like
Yes.
like arbitrarily even. That's cool. That's really cool. Um, okay, so let's go back here. So what do you have in here? So this is the bag of the sum type. So these are the constructors that we already have seen. And this is the pattern.
No, wait. That's important. It's not the ones that we have seen exactly, right?
Wait, then I am confused because this was the case all along, right? Or am I
No,
wrong?
remember that the initial sum state is derived from the type sum, right?
Oh, okay.
So
So this is actually the bags for all the constructors that we know we can have.
yes, exactly.
So you can have you already have the left and the right there for sure, but maybe like they are not they are empty inside. Let's say
Yeah, inside they are not satisfied.
exactly. Yeah, that makes oh man, that's a crucial detail. Yeah, so this bag, because of this behavior of the list map here, this bag is never empty. It is
Yeah,
always contains the.
yeah, go back there just to pinpoint that to Mageta.
Okay,
Uh, how can I
can I
say it?
try?
Yes.
Okay, so Mageta.
Wait, let me close the thing. I finally committed my thing for work. Anyway,
Okay, so the detail that Nathan wants you to be aware is that this get initial state, when you have a sum type, it doesn't work like the integers that it starts empty or the maybe that starts like none. You see, because we are grabbing all the constructors that we know we can have because we have them here, and then we are initializing all their bags using this map here.
yeah, makes sense.
So the important fact is that this behaves kind of differently than the int and the boolean cases because there is no state in which the bag is empty for the sum. The bag is always fulfilled with all the possible constructors that a user can try to pattern match. The
Mhm.
What happens is that the internal bags
can
are
be
not
X
satisfied.
exactly. The internal bags can be empty. You see, or not satisfied, as Nathan said.
That makes sense.
Uh, that's pretty cool. That's pretty cool. Okay, so then you call something next constructor states in which you pick all the available constructor states and then you map them. So this is the name and these are the states. So this is the internal bag of the left, let's say, and this is or the internal bag of the right.
Yeah, internal bags, yes.
Yeah. uh, Then you do what? Then you see if the identifier that you're using try to pattern match is this name here. If it is, you're gonna call the function getNextState for the internal bag. Yeah, yeah. But you're gonna do that for all the possible patterns
So I'm
that
updating the
here.
internal bags of a specific constructor, right?
Yes, exactly, exactly.
And a reason we don't have more checks there is because we already did, like getting the binds.
Yeah. Okay. Then after that, you just return the a tuple, having the name and the next constructor state. So this is already checked the internal bag of this constructor.
Yeah, updating, yes.
Updating, sorry. Yeah. Then you grab that list of tuples. You grab that list of tuples. And you do a list for all. So you're doing second first. So that means that you're grabbing the internals. And
Yes.
you're checking if all of them are satisfied. That makes sense. You're checking if
Because
all
if
the
they
yeah,
are,
yeah, yeah, yeah. Dude, this is really cool. Like, I'm really surprised it is like this. I was expecting much more like janky, band-aided
Wait.
code.
it sounds kind of simple, right?
Okay, and then you're piping that to see if all of them are satisfied. You're cool, but if some of them are not satisfied,
Just go on.
just wait. Should that be an error? Shouldn't that be an error?
No,
Why?
because on my bag, I'm looking for all the constructors, right, of a given sum type. But I can only match one constructor at a time, right? So what I mean is, I'm
Oh,
looking
maybe it's
to,
gonna come later.
yes, I'm looking for
Yeah,
left and right, but I can only do one at a time, right?
clever. Yeah.
So suppose I'm doing the left there. If after updating the internal bags with the left pattern that the user just sent me, then I need to see, did that like satisfy all my things? If so, satisfied. If not,
Just go
go
on.
on, right?
Yeah, just go on. Yeah, you can have like left, and then 90% of the pattern is satisfied, but then you can have another left afterwards that fulfills the entire thing later. Yeah,
And
so that makes
all the
sense.
things about being unreachable there are just being handled by the recursive calls, right?
Wait, but and then that's the end, right? This is basically a safe catch-all to fail.
Yeah, that shouldn't happen because it was validated on the get binds,
I have a
right?
question though.
Okay.
Uh, is this function also checking for exhaustiveness then?
No, there is no way to check for exhaustiveness if you
Oh,
haven't.
this is doing in a single manner. It's actually is you're doing one at a time.
Yes.
So yes.
By the way, that's the key, Leonard. That's the fucking key. You've been able to do state by state iteration one at a time. That's the fucking key.
Yeah, that makes sort of sense. So this is not the checking for exhaustiveness. This is just updating one by one, one by one.
Yeah, and like we know, right? The only way to know if it's something is exhaustive if you went through all the branches. That's
Yeah.
different to check if it's unreachable, right?
Yeah, that's
That we can know
different.
on
Yeah.
the middle, right?
We can know traversing the thing if something is
Yes.
unreachable, but we can only know if the thing is exhaustive after we finish.
Yes.
Okay.
So it's after the fold that I even check for exhaustiveness.
Okay. So this is type checking.
Yeah, now it's the main
Okay, so
dish.
this is the main function. So this is type checking. So
The first thing to notice here, Lemos, I'm
what?
not matching any type. I'm not matching any pattern.
You're not matching any. Wait, can you repeat that?
Yeah. Uh, I'm not matching any type. I'm not matching any pattern.
Oh, I see why you're talking like that.
They are between like just equally, right?
Yeah,
The functions that I'm calling are the ones who do the pattern matching.
yeah. So I'm assuming that this is all like like just to go to the main event, which is
Yes,
this.
yes.
Okay. Okay. So let's go then. So this is the value that you are trying to match, right? And these are the
Yes.
possible branches. Yes.
Yes.
Then you type check the thing that you want to match. That's we need to do that. That's 100% okay. Then you have a folder.
That's the one I wish to use a where, like in Haskell, this folder, because it's so big.
Yeah, it's kind of big, yeah. Okay, but this grabs a bunch of tuples.
Yeah, skip the folder for now. Like,
Skip
let's
the
read
folder.
how
Okay.
it's being used and
Okay,
publish.
so skip the folder. You're gonna go to this.
Yes.
Okay, so we gonna do a fold with that folder that we skipped using a tuple. I'm very curious to know why this is here. This.
Okay. That's the type that the body should have. That the bodies, right? All the bodies of the branches.
This is the body. Okay, so okay, but then the folder will tell me what is going on with this. And then this is basically giving me all the initialized bags.
Yes.
Okay. So you check if you're satisfied. If you are satisfied, done. And if you're not satisfied, then you know for a fact that you already are non-exhaustive patterns.
Yes.
These patterns match to the type to give information about what is left. Yeah.
Yeah, that thing about, oh, this is non-exhaustive. Maybe, well, you can, how can I say?
Oh,
Like, there is
okay.
still one, like, to match, right? You can do that kind of
Yeah.
stuff.
Okay, so if you return unsatisfied, oh man, that's really clever.
Yeah.
Because if it returns unsatisfied, we know that something is wrong based on that get next state function that we read.
We can give a suggestion of what is left to match the. That's really awesome.
Okay, so only remains to read the folder, I guess. So the folder, it grabs a tuple as the initial state of the fold, and then the thing that she's gonna, the elements are the triplets. These I recognize, we do have that. So what we do, we get the binds for the pattern. Yeah, we get the binds for that. We add those to the environment. That creates a new environment. That's
Yeah,
fair.
there is no merge in the maps of F sharp.
That's fair. Then you do a function called check guard, which I'm expecting to be down here. So to check a guard, you pick it, then you type check it using the environment that you received. Then you check if that is a boolean, and if that's a boolean, then you're fine. If it's not, it's a problem. Yeah. Okay, so this is just checking the guard. Then the body type is basically grabbing the new environment that we just updated using the binds and the body, which is here, and then we type check that. Then we check match body, expected type, and body type, which is down here. So, oh, this is because of the, wait. The expected type starts with none, right?
Yes. Because we don't know what should be before going to the first branch,
No,
right?
that I understand. What I'm not understanding is that if this is none, this map will do what?
Well, it's the mapping of an option.
What?
Oh, it's the mapping of an option.
It's a map of an option. But isn't a map of an option mapping the thing inside a sum?
Inside the.
Yeah, if you map a nothing, you get nothing, right?
Yes. Yes, that's exactly what I did this.
Wait. Wait, I'm so confused right now.
Okay, so we have this. Take a look on what we are pattern matching on the end.
Pattern matching at the end. Wait, pattern matching which end?
The function that we are taking a look, the check-in body.
Oh, okay. So check match body, this is none.
No, yeah, go inside check match body.
Okay.
So you see there what like the two last lines of the file, literally the two last lines of the file. So if it's none there, it's okay. Why is it okay? Is it okay because I don't have a expected type yet? I'm on the first iteration, right? That's why it's fine. It's fine being a none, right? If it's a
Oh my
sum,
God, I see. So you created
right?
the none in the beginning to be able to skip the first case.
Yeah, I could do a head, but well, I'm safe and such.
I see, I see, I see. Yeah. Yeah, that makes sense now. So you are doing like that because you didn't want to do a head because that's unsafe. Yeah. Okay.
Or do they want to match to do an exception like saying it should not happen, right?
Yeah. So you do a get last next state, checking if the guard is a sum.
Because if it is, then it doesn't matter, right? Like I'm not sure that these how can I say that? Well,
Wait,
if you
that's
have
kind
a
of weird.
guard,
Huh.
yeah, it might be. So if you have a guard, uh, that pattern that you have on the same branch will not contribute to the progress of my satisfaction.
Oh, I see. So if you are using a guard, we are jumping the your entire state changes that you would be doing. Because you have a guard, we don't care. Yeah. And that makes sense because if you're not a guard, that means if you don't have a is not a sum, that means that you have a guard. Then we need that. Then we need to update it. That returns the next state, and then this fold returns a
Problem there?
sum.
Wait, wait. Do we have? Wait, we might have a problem there, don't we?
Go
Wait.
on.
So I was thinking only about the case of does this contributes to progressing the satisfaction? It doesn't, I guess.
It doesn't.
But what if was a pattern that would trigger the unreachable case? Is that a problem then? You
Wait,
see?
I don't see the relation there. How are we gonna know that a thing is reachable or not based on the having or not having a guard?
Let me write a piece of code. So let's suppose you have someone, right? And you do something,
Mm-hmm.
but you also have someone, but you have a guard with it.
Does that mean?
Yeah, that's what I want to know. So in that case, I'm not calling the next state in the someone, right?
In the well, in the second someone.
Well, yeah, in this second someone,
Yeah.
right? Because
In the
it,
second someone, like that's.
yeah. So yeah, so should this give a warning about being unreachable? Like me having a guard? I have no
Oh,
idea, I guess. It's very easy to fix, but I don't know what should happen. The fix would be call get next state anywhere, but if you are going to return or not, then that is the condition for the is sum, right?
I think I see. So what you're talking about is that when you have a guard, we are not even checking reachability in that branch anymore. And
Yeah,
then
we
we.
know
Hmm.
doesn't care for progressing satisfaction, but should that give a warning about unreachable? I don't know.
Should that give a warning about unreachable? I think it
Yeah,
should. I think it should.
I will check with Okamo, but let's go to the rest of the.
I'm gonna check with Tokem. I wrote the thing in F sharp, but I'm gonna check it with
No,
Tokem.
no, no, no. Yeah, because as we saw already, F sharp has a lot of flaws regarding pattern matching.
Can't argue with that.
Yeah, okay. So, question then. Question. Why is this returning? Wait. This is a
Oh,
tuple,
wait.
right?
Yeah, just give a look on like.
Oh, no, 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 no. Makes sense, makes sense. This is some of the body that we made using the check match body to jump the first case using the none. and this is the next state of the fold, and then we're gonna fold again and again and so on and so
Yeah,
on.
just something. Go a little bit down.
Go a little bit down.
Oh, okay, yeah. So there is just a warning, right? Case is not unsatisfied. I thought I have used a fail with for some reason, but it's fine, I guess.
Yeah, it's fine. It's gonna fail with. Yeah, yeah, it is indeed very. It needs cleverness. That's why we couldn't make it in the first 5 attempts. Okay.
It's hard to do on the spot, right?
Okay, so 100%, like 1,000% easier than doing the vertical whatever check exhaustiveness separately. Like it's not even comparable in my on my books. It's so much easier to do like this.
For me, that's the main thing. Inside the branch of typing check in a matching expression, I'm not pattern matching any type or any pattern. There is nothing specific there.
Yeah.
That's the point to me.
Holy, holy. Okay, but let's do it then. Let's start with the types up there. But congrats, Nathan, that you made this. Really congrats.
Good luck with your
I
Haskell
didn't see how
code.
we pattern match records.
We don't.
We don't.
That's the
No
easy.
records nor tuples.
No, no, no.
Nor
But that's
lists.
no. But that's the thing. We don't do the records because we don't even have them yet. We don't have nominal records. We have to make them.
Yeah, we just have the anonymous, right?
Yeah,
Yeah, but
we only have the
yeah, but
anonymous.
that doesn't explain why I didn't decode for that.
Yeah, that doesn't explain, but.
Oh, yes.
Because that's a whole lot of work, dude. The tuples, it's probably harder than everything that is there.
Why the tuple
Maybe.
is harder though?
Because you're generating what's the name? Like Cartesian.
Cartesian product?
Yeah, right? So how do you check? Like for example, if I choose 1 on the left side, then the right side should be like exhaustive, right? But then if I use 2, then it should also be exhaustive, right?
Yeah, it's exponential.
Yeah, so how do I check that shit, dude? Especially using the fact that I'm like initializing the empty bag, right? What the fuck, dude? How will I do all that? Like,
I'll go have dinner. I'll be back.
Yeah.
that is
Okay.
a chance that will be quite hard, but I don't know for sure.
Yeah, but we already said that in the beginning. Like, this is not the first time that we say pattern matching is hard. Oh, who'd have thought?
And it was. And it was, dude. We were not wrong.
Yeah, that's that's for sure. But I'm so glad it is possible to do in a single thing because doing like what we're doing right now, which is check exhaustiveness separately, and it depends if it's infinite or not. Holy Jesus! Like I. Dude, I'm so glad it is possible.
It's literally trying to, how can I say, to do a campfire, like to initiate the fire, just throwing rocks at the ground, dude.
I don't know if
Like,
I would compare
the
like
way we
that,
were
but that's
doing.
okay.
But I mean, we were doing the hard way about everything.
I don't know about, but that we you can't say we couldn't say that at that time, man. It's exactly
Yeah,
what you
we
said.
could.
Like you said it. We don't know. We have to try it.
No. Yes, but now we know it
No,
was the hard.
now we know. I agree, but now we know. But still, that's more than a. Like that's okay. I am totally okay with like we tried, we had an idea, and we managed to make it, right? We made
Yeah.
check exhaustiveness for it only with the sum type. And then we said, "Oh, this is really bad."
And that's so weird, right? Because if you do pattern matching for some types, only some types, and non-nested some types, it's so fucking easy to do it, man. The checks. It's incredible easy. You just check if the branches are exactly the same things as the constructors, and that's it. right? And then you just say, oh, let add nested stuff, and suddenly the thing is exponentially harder, dude.
Yeah, I have to agree. Exponentially harder. I think we are okay on here. So, bye. Okay, what's the next one? The state definitely is the next one. Do we need anything from here? This is the same. Here, this is because we are not using constructors as functions as we are. I already update that. And this is the same as we have. Okay, so it's just this. So let's call it. What's gonna be the name of this guy? State is bad. Um,
Satisfaction.
no, satisfaction is still not great enough because it is not all only being a state, a Boolean state of satisfied and unsatisfied. You also have data there now.
Yeah, it's really tricky to name that because you cannot also say previous matches or looking for it,
Better
right?
match state.
Yeah, that's the state, but being specific, right?
Okay, so you can be satisfied. You can be. Well, we can't use the literals unfortunately because of that problem that we need to be able to. We need to be able to do the thing. Oh my god, you named it bool and int.
What?
Yeah. How in the
Just
balls?
prefix all of them, right? Something like, I don't know, PS, pattern state, matching state, mass, something like that.
Okay, so this is a
But
maybe.
isn't it weird if you do only one of those, like prefixed?
Yeah, you want me to do. Oops.
If you do prefix all, right?
Yeah, you want me to do this. Right?
No, I'm not saying that you should prefix all the types, but inside the type, prefix all the constructors, right?
Yeah, but that's. Wait, I'm confused. What do you mean? The constructors, you mean.
Yeah, so if you are prefixing something in pattern match state,
Mm-hmm.
maybe you would want to prefix all of it.
Yeah, and all of them have S in the beginning.
Yeah. Yeah, but you prefix the same thing that you are doing in state, right? Oh no, that's just for reference, right?
Yeah, that's just for reference. So this is a tuple in which we have a label, and then you have another list here, which is pattern uh, match state, and then we are basically done. Um, yeah. Okay, so it is complaining about something in syntax. Parse. Oh, it is the first one because it does not follow the same thing there. We don't have label here. That's that's really weird. Yeah, I'm gonna do my get style because I'm losing my patience with these imports. So yeah. So then we have that. We have the state for the pattern match state, right? It's exactly what it is. Uh, Now we need to grab the functions themselves.
Dude, I
Wait,
just checked.
what?
I really need to fix the code. And it makes sense, right? If
Which
you have
code?
this, the gist, right? With the
This one?
thing with, yes,
Where? Which part?
uh, the part of
The guards?
checking, yes,
Oh,
yes,
here. Yeah, you can do that.
yeah, this part. Because I was checking here in Nekoma and it really throws a warning. If you use a pattern and then do the same pattern but with a guard, indeed, like, doesn't matter what your guard result is, it will never match, right?
Mm-hmm.
Like, because you just did the same. But if the opposite happens, then it's okay.
Mm-hmm. Yeah, no,
So
that makes sense. You
yeah,
can
I
feel free
fixed
to
that.
yeah, feel free to update that. Um, okay, so let's see how. I'm probably gonna do this. Like, I'm not gonna continue doing here until we reach the 2 hour mark. That's totally fine. But I'm probably gonna continue translating these offline because there's a bunch of things to translate, and I do have to pay attention that because you're doing like something simpler, you're not doing the whole handling of like doing. You're only failing, like fail.
Yeah, exception will make hard for you.
I need to think about that. So that's something to be aware. So let's make the create binds function. What's the type of a create binds function? It's something that takes a type. That's definitely, and it in a pattern. And what that results? That results result t in a list of binds in which you have a label and a type. Okay. So this is what we want. This is what we want. So let me think about that. So if you have whatever, but you have a p wildcard.
Dude, I'm telling you, F sharp has a fucking joke for pattern match, man. It doesn't give the warning that Okami does. I'm telling you, man, like literally. Our language you have better pattern matching than F sharp. Besides from the active pattern.
Dude, that saying that out loud is so hilarious.
Well, it is true, right?
Like it even dude sounds wrong, you know? Sounds wrong.
Let's see, but
Because literally, dude, literally, um, F sharp is like a full blown language.
yeah, yeah, exactly.
This is just a draft of that some weirdos did in their free
It's
time.
just one file. No, I mean, sure. We are not better in the sense of they have much more cases,
Oh, for sure.
but there are cases in which they are not doing good enough. Just as simple.
Yeah, I have to totally agree with that. So, P disjunctive. Let's call. I need to make the names better as well. Um, I'm gonna call this one first pattern and second pattern.
How is that better than pattern A and pattern B? Are you crazy? By the way, the first draft was left pattern and right pattern, but then I changed.
Oh man, so good. Create binds, passing type prime, and the first pattern. Then second binds, uh, create binds type
Oh, by the
prime.
way, what was the project setup to do the gist? Basically, I have a front-end project in F Sharp. I just open it and start to code in there to get compiler warnings and errors, man.
Wait, you have what? You have a front end?
Like, I have another project in F Sharp, like one that I have here. I just use it to host my gist as a parasite.
But have you make it? That older project that is like drive the driver, is that the one that you made it?
What do you mean the driver?
Yeah, the one that you're using to use this one as a parasite.
Yeah, okay.
Does that one is like a thing in F sharp or is you made one?
No, I had to do some project here in F Sharp, and
Oh, I
then I
see.
had it here, right?
Oh, I
Then I
see.
use it instead of creating a new one for this.
Oh, I see. I see. I see. Okay. Um. Okay. So the first thing is that we want to sort. We want to sort two lists, but I need to double check. Yeah, I always forget this sort of information. That pisses me off a bunch. But okay.
You have a lot of nested lists there, man. It's not normal to keep track of all.
No. But I always no, not about that. I always don't remember, and this is wrong. This should be 3 and this should be 2. Made what? Wait, so if I ask to sort a list of tuples, that is not sorting using the first member of it? Why? Hmm. Oh wait, this is wrong. Okay, I'm dumb. Okay, so this is the tuple itself doesn't matter at all. This can be whatever. The problem is the first one. So this is 2. Let's put 4 actually, and then we will ask sort. Oh yeah, I don't need to do any of that. I just ask sort. Okay.
Wait, you have to take care there. Do you want to sort by what?
What do you mean?
By
You are sorting by the first,
key
right?
only? Yeah, well, I don't know.
Well, what do you mean you don't know? It's there.
Oh, okay, yeah, I was not seeing the code there. Yeah, you shouldn't assume that at all in Haskell, dude.
No, but I did. I just tested.
Oh, you just tested.
Yeah.
Wait, you are saying... Dude, wait. What is the type of sort? Like, what is the type class that it requires? Ort?
Yeah.
What is the implementation of that for the...
Probably the first.
Well, let's just check that if you have that information.
Okay, so how can we check that? We can ask for less than. Okay, so let's ask that. So 1, 2 less than 2, 3. That should be right, correct? It should be true. And if I put 1 here and 2 here, that's false.
Yeah, but yeah, that doesn't prove shit if you are not changing the others also.
No. Okay, so let's put 1 here.
Okay, now you do the last case, right?
Yeah, it's always the first.
Wait. No, you haven't tested the case in which is... Man, go on. I will check the fucking code. They implement this.
Go on. Okay, so sort first binds equal to sort second. If that is a thing, then we just return pure whatever you decided to use first. Why not? Else, we're gonna throw an error saying something in the lines of type error. What is the type error in this case? So both sides of the OR pattern need to have the same binds. Okay, so let's pick P here. And let's say something along the lines of printf. And let's say both all not all the possibilities in the OR pattern this have the same binds. And then you just do show P. Yeah, that works. Next, create binds.
It's raining like so heavily here. It's legit scary.
P S.
Dude, you have ordering for units. What the
Really?
fuck? Yeah.
That's unexpected. Yeah, but Magneto, what we're doing, we're basically translating right now. I already translated the type. I'm just making the binds now. I am already in the S, which is down here. Then we have the sum, which takes more space than the easy ones down there. Yeah, so let me actually check if, yeah, pattern label. There is no comma there. So it is like that. So you do let bind. So this is a do binds. Create binds using type prime and pattern prime.
That's interesting. That's very interesting. Apparently, it doesn't order by only the first two. But I haven't saw the code yet.
Okay, so this is a case find.
By the way, you're using sort, right?
Yeah.
Sort you. Oh, okay, I will check here.
So this is equal label with a first, and you're gonna do that on binds, and then off. If you find nothing, what does that mean? That means that we are good. Yeah, that means that we are okay. So this is gonna be label, type that, cons, binds.
Wait, where do I find sort?
Just go on Google and type sort. I think it's in
No, yeah.
data.list.
This typing is just stupid. Down there on the LSP.
Wait, what?
The typing on the LSPs is stupid.
You mean
Like on the mini buffer.
oh the dollar there and the other crap?
Yeah, dude.
Yeah, that's Kung Fu. That is from the beginning. Okay, so this is throw error. Which type of error are we gonna throw in this? There is this in here. He said error about repeated by name in the same pattern.
Wait, let me come up with a corporate way to say the same thing.
Okay, so definitely we're gonna have to use the pattern that we have the problem. We're gonna say something along the lines of type
Recurrent pattern was identified.
recurrent label identified in pattern.
Was identified.
Yeah, that's good enough. That's like enterprise enough.
Yes. You forgot a dot in the end, by the way.
The dot at the end here?
Yes, that's
I
it.
don't think
Now
we
it's
have
okay.
dots in the errors
Oh, we
though.
better have.
We better let's do that later then. The next one is the one that really matters. So this is the T algebraic. We are gonna call that constructors. And we're gonna have a pattern which is the P sum type, I'm assuming. So P sum type, this is the label, and these are the patterns. So then we're gonna do. Okay. So the first thing that we do is to get the types from the constructors. Okay. Wait, Nathan, are you there?
Yes.
Oh.
I have a question. This returns an option, right? This try find.
Yeah.
So if types is none, what happens to everything else? Oh, it doesn't because you fail. Okay.
Oh,
Okay.
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 Yeah, like you haven't found the constructor on the type, right?
Yeah. No, I'm not. Yeah, that makes sense. So what we want to be able to do is to do a try find. Okay, so this is basically case find. Um, Label with the first on the constructors of. If we find nothing, that we are done. Throw error. Throw error. Printf type error. So what we want to be able to say is could not find uh, constructor with name this.
No, man, you use the passive voice, man. You don't know how to write like this boring text, man. You gotta be something like could not be found, and then you say the thing.
Okay, so name this. This could not be found.
Lemus, I guess they are using deriving instance in the tuple case for ordering the
I don't know what
like
is that. I think just
that deriving instance.
yeah. Uh, da, 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 da. These are the types.
Yeah, I guess that's supposed to be some default implementation, right? Deriving, but how? Like,
Wait, how? Where?
what?
What?
I was looking for the instance in which they implement. Oh, yeah, in which they implement the instance for ordering, right, in tuples.
Mm-hmm.
But then when I go there, they just have deriving instance. That's it. They don't have an implementation.
Mm.
Like, the fuck?
Yeah, I don't know what the derived instance is doing there.
Yeah, let me look further.
Types. Oops. So this is another throw error. Printf. Uh, and type error. This error is when. Oh, this is when you have a to do in the. The fail is a to do. Error about the different lengths in types.
Yeah,
Different.
this part of the code can be done like much, much better, dude. But yeah, it would be work.
Um, no, we need to say list of types. This has a different length than the length of list of patterns. This show types and show patterns. Yeah, and in here is just appear. Okay, so something is complaining there. Oh, I think I know. It needs to be like this. Yeah. And it doesn't have a dollar in this case. It's just that. Yeah, that's not a problem, dude. We just need the types that. What the heck happened? I have no idea what happened there. That's okay. Yeah. Okay, so now I need to see what is going on wrong there. Oh no, that's a problem because I don't have the return type correct. That's okay.
Yeah, I haven't found the implementation, but I know a way to assure the thing. There is something called sort with, right?
No, yeah, no, but that no, I agree with you that you can use a sort with, but we can use just a sort.
Yeah, but you don't know for sure if that does what you want.
But we tested. What do you mean?
I'm really not sure about those things.
What do you mean?
Really not sure, especially after seeing what is the instance for it, despite not seeing the implementation because I have found one.
Zip with them exists. Cool.
Always zip, man. Whenever I look, Lemos is typing zip.
No, but this is the same as this his thing.
Yeah, and here he goes trying to justify the zip.
No, but it is, dude.
I'm just bugging
He
you,
even
man.
said.
I'm not even paying attention, that much attention to say this.
Okay. So this is gonna be create binds. Then I need to pass the types, patterns. Right. Yes. Okay. Then we have this check. What is this? This is a holy Jesus. This is a fold. Yeah, this is a fold. Okay, so this is a fold M. This. I'm gonna make that after. We're gonna have. Do we have set in this? We do not.
Look at those imports, man.
Yeah, but this is because of company modes. Data set as qualified. Uh, yeah, so then we're gonna do s empty, and the thing that you're gonna do there is mapping first to binds. Yep. Okay, so what the heck we're gonna fold? We're gonna do a this is a fold left, so we receive the accumulator first. So this is an element. What we're gonna do with that? We're gonna do an if s contains. Is that the one? Data set. I think it's member, not contains. Member. Oh yeah, is the element in the set. Yeah, so member. And you pass the element L. Then, if that's the case, what you're gonna do about that? You're gonna fail because there's a repeated bind there. So this is a throw error. Um, type error. Repeated bind found. I'm trying really hard to do the enterprise.
Enterprise thinking, man. That's it.
That's the problem.
That's a problem. Insert. Yep. Yep, that's correct indeed. Okay, last step. Is this? Oh, we just return it. Okay, so pure binds. I'm guessing. Okay, so now I need to. I think I probably have the order wrong there. So let me do that. For them. This. The accumulator, then the element. Yeah, that's correct. So what is the problem, my dude? I am picking the list of binds. I'm mapping first on it. Then I'm grabbing a set, an empty set. and I am using that to iterate on, and the function that I'm doing that is actually wrong because this is that. Yeah. What is the type of this? Wait, I think I'm missing something. Oh, you need to do the concat, dude. The concat. Concat. Okay. Done. Now I just need to do all the other ones. These ones. Create binds tint. And the pattern that we want is a p literal with L integer ignoring the value. And all of them will be this. It's not t int. We call it t integer then? Yeah. So we have one that is integer, one that is bool, the t unit. Bool L unit. Ooh. Okay, so this and this. Yeah, Emacs went totally crazy. Great. Okay. And for now, I'm just gonna do I get the style here. Throw error. Type error. Error about pattern not being valid. Pattern this not valid for type that. So type that and pattern that, and then show pattern and show type. Okay, one done. One function is done.
Oh man, I think I will run out of power.
What do you mean? Is
It's
it raining there?
It's raining very heavily, and
Mm-hmm.
the lights are flickering.
I see. Okay, now the big boy. Get next state. Well, we already finished the 2 hour mark, so I'm gonna finish the streaming thing.
We can start compiling.